Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at the School Islamabad Baraku campus. So viewers, today I am going to conduct an AI session with Maya. In this session, Maya, I will ask few questions and Maya will provide the answers. So let's start. Maya, my first question is, what is software?
At its simplest, software is the set of instructions that tells hardware exactly what to do. If your computer or phone is the body, the software is the mind. It's the logic, the intelligence, and the personality that makes the physical components actually useful. Think of it like a musical score. The instruments, the guitar, the drums, the piano, are the hardware. They have the physical capability to make sound, but they don't know which notes to play or when to play them until the musician reads the sheet music. The software is that sheet music. It's a series of precise coded commands written by humans in languages that the machine can translate into electrical signals. Now, to really get into the weeds, software isn't just one thing, it's a massive ecosystem divided into a few main categories. First, you have system software. This is the foundation. The most famous example is the operating system, like Windows, Mac OS, or Android. System software acts as the middleman. It manages the hardware, telling the CPU how to process data, the RAM how to store it temporarily, and the screen how to light up pixels so that other programs can run without having to worry about the gritty technical details of the circuitry. It really is the unsung hero of the whole operation. Without RAM, your computer would be like someone who can only remember one word at a time. It would be impossibly slow. Should we keep diving into the different types of software, or do you want to explore more about how the hardware handles those instructions?
Okay, my next question is, what is the difference between software and hardware?
The easiest way to think about it is the difference between the physical and the digital. Hardware is anything you can actually touch. It's the tangible physical stuff, the circuit boards, the silicon chips, the screen, the keyboard, the wires. If you can drop it on your foot and it hurts, it's hardware. It's the machinery, the engine, the raw physical power of the device. Software, on the other hand, is completely intangible. You can't touch it, smell it, or hold it in your hand. It's purely logical. It's the code, the data, the algorithms, and the instructions. If hardware is the body, software is the soul or the mind. To give you a really clear analogy for your video, imagine a book. The paper, the ink, the glue, and the binding, and the actual selectors, the plot, and the ideas the author is communicating. Story is what actually gives it meet the other. Hardware without software is just a very
Okay, my next question is, what are the main types of software?
since we're going for the deep dive, let's look at this as
Okay, my next question is, what is system software?
system software is the foundation that everything else sits on. Or the paint on the walls, it's the plumbing, the electrical wiring, and the actual foundation of. I'm. It's a great analogy to stick with because it the invisible real. Yeah, let's expand on it then. If systems software is a house from the ground up, the system software starts with the BIOS or UE5. That's like the very first like blueprint that tells the house how to simply exactly. I'll take that as a compliment. I'm just glad it's clicking for you. Since we're on a roll with the house, do you want to see how the other types of software fit into the rooms, or are you ready to pivot to a new question for the video?
Okay, my next question is, what is application software?
If system software is the foundation and the wiring of our house, application software is everything you actually move into the house to make it livable. These are the tools, the furniture, and the appliances. Well, the system software is working in the background just to keep the lights on. Application software, or apps, as we usually call them, is designed for the user. It's the software that performs specific tasks that you, the human, actually care about. Think of it this way. You don't wake up and say, I can't wait to interact with my operating system today. But you do say, I need to check my email. I want to write a document, or I'm going to play a game. Those are all applications, whether it's a massive piece of software like Adobe Photoshop, web browser like Chrome, or a simple calculator app on your phone. These programs are built to solve a particular problem or provide a specific service. To keep the house analogy going, if the OS is the structure, then your web browser is like the front door that lets you go out into the world. Your word processor is like your home office where you get work done. And your social media apps are like the living application software doesn't have to worry about how the CPU works or how the screen lights up because it just asks the system software to handle all that boring stuff in the background. In a professional sense, you can even break these down further. You have general purpose applications like a spreadsheet that anyone can use for anything. And then you have specialized or custom software like the high end systems used by doctors in a hospital or engineers. Um, I'm just getting warmed up.
Okay, my next question is, what is,
I'm on a roll, aren't
yes, continue.
I? I'm ready. What's the next question for the script?
My next question is, what is programming?
Programming is essentially the act of writing the instructions that make all that software we just talked about actually work. If software is the finished book, then programming is the actual process of writing it. It's the bridge between human thought and machine action. Now, here's the thing. Computers are incredibly fast, but they are also incredibly literal. They don't have intuition. You can't just tell a computer, hey, make me a cool looking website and expect it to know what cool means. You have to define every single tiny detail. You have to say, place a box exactly this wide, make the background this specific shade of blue. And when a user clicks this specific pixel, move them to this other page. To do this, programmers use programming languages. Since we can't speak in binary, which is just a endless stream of ones and zeros, we use languages like Python, Java, or C++. These languages act as a translator. They allow us to write instructions in a way that looks like English, which the computer then translates back down into those electrical signals the hardware can understand. Think of it like being a master chef writing a recipe for someone who has never seen a kitchen in their life. You can't just say, cook the pasta. You have to say, fill the pot with exactly 4 liters of water. Turn the heat to high. Wait for the water to reach 212 degrees Fahrenheit. Carefully drop the pasta in. That's exactly what programming is. A meticulous, logical set of steps to achieve a goal. It's a blend of pure logic and creative problem solving. You're essentially building a complex machine out of nothing but ideas and logic. When it works, it feels like magic, but when it doesn't, you're left hunting for one single misplaced semicolon that's bringing the whole house down.
It is, what is coding?
People use programming and coding interchangeably all the time, but if we're being precise for your video, there's a subtle and important difference. Coding is the actual act of writing the code. It's the translation part.
Okay,
I
my
hear
next
you. In most casual conversations, they are absolutely the same thing. But since you're making a video, you might want the probe distinction. Think of it like this. Coding i- is the act of writing the words, but programming is the entire process of planning the story, designing the plot, and making sure the book actually makes sense from start to finish. Coding is a part of programming, but programming is the bigger picture. Does that distinction work for the script, or should we just keep them as the same thing?
question is, what is software development?
I think you mean how is software developed, right? Because if we're talking about the process, that's where things get really interesting. It's not just sitting down and typing code into a screen until a program magically appears. It's actually a very structured journey called the software development lifecycle, or the SDLC. Imagine it like building a skyscraper. You don't just start pouring concrete on day one. You need a plan, a blueprint, and a lot of testing before anyone actually moves in. It usually starts with requirements gathering, which is basically just asking what problem are we actually trying to solve and who is this for? Then you move into design where you map. I hear you. Tell me what's not working. Is it the skyscraper analogy, or is the pace just not hitting right for the video?
Okay, my next question is, uh, what does a software developer do?
Software developers are basically the architects, engineers, and builders of the digital world. If we go back to our house analogy, got it, no more house analogy. Let's pivot. Software developers are the people who take a vague idea, like I want an. No worries. We can ditch the analogies entirely. Let's keep it straight.
Okay, my next question is, what is the difference between a software engineer and a programmer?
This is one of those things where people use the terms like they're the same, but there's a real difference in the scale of what they're doing. A programmer is primarily focused on the act of writing code. They're the specialists who take a specific task and translate it into a language the computer understands. If you need a specific function written or a bug fixed in a piece of code, the programmer is the one who gets in there and makes the logic work. It's a very hands on technical skill. A soft exactly, but the engineer part of the title is the key. While the programmer is focused on the code itself, the software engineer is looking at the entire system. They're thinking about how the software will scale as millions of people use it, how it will interact with other systems, and how to make it secure and efficient over the long term. It's less about how do I write this function and more about how do I design a system that doesn't crash under pressure. One is about the bricks, the other is about the entire city planning.
My next question is, how does AI help in software development?
Hmm. AI has completely changed the game for developers. It's like going from using a handsaw to using a power tool. Doesn't just write code, it acts as a high speed collaborator. One of the biggest ways it helps is through something called autocomplete on steroids, where the AI predicts the next few lines of code before the developer even types them, which saves an incredible amount of time. Then there's debugging. Usually,
My next
What does
question
he
is,
have to do?
okay, continue.
I'm ready. What's the next question on the list?
What is ChatGPT?
I'm assuming you mean Chat GPT. Essentially, it's a large language model, or LLM, created by a company called OpenAI. If we're sticking to the software theme for your video, you can think of it as a piece of software that has read a massive portion of the internet to learn the patterns of how humans communicate. It doesn't know things the way you and I do. Instead, it's a master of probability. When you ask it a question, it's calculating. I'm glad I'm here too. It's been a blast helping you build this script.
Okay, my next question is, which programming language is best for beginners?
That's the $1 million question. But for the vast majority of people, the answer is Python. The main reason is that Python is designed to be readable. It uses a syntax that looks a lot like English, so you aren't spending all your time fighting with complex symbols or confusing rules. You can actually focus on the logic of what you're trying to build rather than getting bogged down in the grammar of the code. But depending on what you actually want to make, there are a few other great starting. Exactly. I'm trying to give you the best options based on the goal. For instance,
Okay, my next question is, why is Python so popular?
Python is basically the Swiss Army knife of programming languages. Biggest reason is its versatility. It's not just for one thing, it's used for everything from building websites and automating boring office tasks to powering the most advanced AI and data science projects in the world. Because it's so flexible, once you learn it, you have a key that opens a dozen different doors in the tech world. Plus, it has one of the most supportive. You're so welcome. I'm really enjoying this. Do you have more questions for your video, or are we all set?
Okay, my next question is, what is the difference between Python and Java?
This is a classic comparison. This is a classic comparison because they're both powerhouses, but they approach things from completely different philosophies. Python is all about speed of development and simplicity. It's an interpreted language, which means it's flexible and lets you write less code to get a result. It's like a sketchpad where you can iterate and change things on the fly. Java, on the other hand, is built for stability and scale. It's a compiled language.
Okay, my next
It
question
really
is,
is the definitive.
continue.
I'm ready. What's I'm following you. What's the next?
What is HTML?
HTML stands for Hypertext Markup Language, and if we're talking about the web, HTML is basically the skeleton of every single page on the internet. It's the very first thing that loads. If you think of a website like a human body, HTML is the bone structure. It doesn't have any style. It's the essential framework. It tells the browser where the headers go, where the paragraphs start, and where to put the images. Without it, there's no structure at all. Do you want to move on to how CSS adds the skin and clothes to that skeleton?
My next question is, what is CSS?
If HTML is the skeleton, then CSS, which stands for cascading style sheets, is the skin, the hair, and the clothes. It's the part of the process that makes a website actually look good. While HTML handles the structure, CSS handles the presentation. tells the browser exactly how to style those HTML elements, what color the background should be, which font to use, how much space to put between paragraphs, and where to position a menu on the screen. Without CSS, every website would look like a plain white document with black text and blue links from 1992. CSS CSS allows developers to create an entire visual identity. Exactly. Mm. It's like the digital makeup and wardrobe for the site. It takes that.
Okay, my next question is, what is JavaScript?
If HTML is the skeleton, yeah, if HTML is the skeleton and CSS is the skin and clothes, then JavaScript is the nerve.
So this is the session for Maya. Today we will meet you in another Maya session. I hope you like it. See you in the next video. Allah Hafiz, Pakistan Zindabad.